Kia ora, Year 12 and Year 11. This is part C and D of question 3 from the 2015 Algebra exam. So there were 2 opportunities for excellence in this question 3, and these are the 2 questions. Right, now both of them are related to understanding the idea of the discriminant in a quadratic. So the first one is, for what values of k does the graph of the quadratic function, this here, never touch the x-axis? Okay, so for that to happen, we require the discriminant, which sometimes we write like that, which is b squared minus 4ac, to be strictly negative, okay, because that's saying that there are no real roots of the equation. I'm not going to go through all of that again now, because I just want to get into the question, which is to apply that idea. So for this to happen, we require b squared minus 4ac is strictly less than 0. So a equals 1. B is equal to 3k minus 1, whoops, and C is equal to 2k plus 10. So what do I have to do? Well, I have to use these values here in this expression, as usual. So you've probably done lots of these problems with numbers. Now we're doing it with variables. So we've got 3k minus 1 squared minus 4 times 1 times 2k plus 10. And we need that to be strictly negative. So expanding, we get 9k squared minus 6k plus 1 minus 8k minus 40 is less than 0. Now I'm going to collect up like terms, and I get 9k squared minus 14k minus 39 is strictly less than 0. So we've got a quadratic, another quadratic, but this one's in k. So now we're looking for the values of k that will make this a true statement. So this is a lot like one that I did with my class the other day, only in a different context. So we're going to keep going with this on a new slide. Okay, so a couple of things to do here. The first thing to do is to stare at it for a bit and just see if it factorises reasonably easily. Okay, now some of you will be lucky and you will see that there aren't very many factors to test on 39. 39 and 1 seems fairly unlikely. Let's just try 3 and 13 and play around with that. So I'm looking for a 9k squared, so that could be a 1 and a 9, or it could be a 3 and a 3. Let's try 9 here, 9k here, and k here. So that would be 9 times 13, that's going to give me 117 minus 117k, plus 3k, so that's not right. Plus, I'd still have a funny factor of 3 going on in here, so let's try instead 9k minus 13 and k plus 3. So if you have a look at that, you'll see 9k squared minus 13k plus 27k, looking pretty good, minus 39. So that's what it turns out to be. Now, if you're really quick at these and you've done lots, you may well spot that. Okay, but most of you probably won't. So I want to make sure that we remember how to do this on the graphics calculator and then get the values from that. Okay, so we've got another quadratic, and we're going to solve this to find the roots of the equation. So k is equal to negative b plus or minus root b squared minus 4ac on 2a. So if we do that, we get k is equal to negative 14, so 14 plus or minus, right, what's b squared? Well, b squared is negative 14 squared, so 196 minus 4 times 9 times negative 39. And all of that is divided by 18. Right, so I'm running out of space, so here's a new slide. So that gives me k is equal to 14 plus or minus the square root of 196 plus 1404. So that should make you happy, because I've got a perfect square in there, divided by 18. So this is 1600, and the square root of that is 40. So we've got 14 plus or minus 40 over 18, which is equal to 54 over 18, or negative 26 over 18, which is 3, or negative 13 over 9. Right, now we can work from here, but I'm going to go show you how to refactorise from this. So k equals that, or k equals that. k equals 3, or k equals negative 13 over 9. So this may come in handy in an easier problem. So k minus 3 equals 0, or 9k equals negative 13, 9k plus 13 equals 0. And look, there we go, we've got our two factors. So we're going to pop those back into our inequality. So we're looking for when that is negative. So again, we're going to draw a number line. I'm saying again for students in my class because we've done a bit of number line drawing for quadratic inequalities. So here's one of the roots at 3, and here's the other one at negative 13 over 9. I want to figure out when this is negative. So it'll be negative up here because I've got both factors. Sorry, it'll be positive up here because I've got a positive times a positive. And down here, this is going to be negative, and this one's going to be negative. So the whole thing's going to be positive. So the place where this inequality is satisfied is in here, where I'm going to have this one being negative and this one being positive. So the final answer to this problem is that k is between 3 and negative 13 over 9. So there you go. Now there was a little bit of extra stuff in there beyond what you needed for that question. Okay, on to the next one, which is another quadratic equation. Alright, quite a similar question. This quadratic has two positive real roots. So that means that I've got a situation something like that. Two positive real roots. Not quite like that, because I know that both the roots are greater than 0. So that one there was just two real roots. This is two positive real roots, so they must be greater than 0. So we have to find the possible values of m, that's the first thing, and the roots of the equation. So if we want to find the roots, we're going to have to use the full quadratic formula, but for the first bit we're just using the discriminant. Okay, so if it's got two positive real roots, this means that b squared minus 4ac is strictly greater than 0, because remember, if it's equal to 0, that's the situation where I've just got one root and it's touching the axis. So we don't want that, so we'll take that away again. So strictly greater than 0. Now, a is equal to m, b is equal to negative m plus 2, and c is equal to 2. So we're going to pop everything into my discriminant expression. We'll get negative m plus 2 squared minus 4 times m times c, and we need that to be greater than 0. So that gives me just m plus 2 squared, right, because this is negative 1 squared, which is 1, m plus 2 squared minus 4m, oh, what's that c doing there? That shouldn't be there, that should be 2, right, so minus 4m times 2, which is 8m. So we need that to be greater than 0, so on to a new slide. Alright, that gives me m squared plus 4m plus 4 minus 8m greater than 0, which is m squared minus 4m plus 4, strictly greater than 0. Now, look at that before you go for your calculator and just see how easy that is to factorise. So it's a perfect square, it's m minus 2 squared greater than 0. So I want to have, well, I've got something squared. So any value of m except for 2 is going to make that a positive number, right? I could have a negative number in here, and when I square it, it's still strictly positive. So m is any number except 2, but of course the more elegant way to write that is just m not equal to 2. So that's the first part done. Okay, and now we just have to find the roots of the equation. So we're going to go back here and we're going to say we've got mx squared minus m plus 2x plus 2 equals 0, and we're going to do the full quadratic formula on that on a new slide. So a is equal to m, b is equal to negative m plus 2, and c is still equal to 2. So x is equal to negative b plus or minus root b squared minus 4ac over 2a. So x is equal to m plus 2 plus or minus the square root of, well, we've already worked that discriminant bit out, right, and that was my m minus 2 squared, divided by 2m. So x is equal to m plus 2, I'll do the positive root first, plus, right, the square root of that square is just m minus 2. Now, I'm going to need to check that, because that is assuming implicitly that m minus 2 is positive, but it won't matter because we're going to reverse it in a minute. So one of the roots is m plus 2 plus m minus 2 over 2m, or x equals m plus 2 minus m minus 2 over 2m. So this first one, I'm just going to squeeze this in onto the slide. I'm going to do it up here. The first one gives me x equals, I've got m plus m, so I've got 2m plus 2 minus 2, so I've got 2m over 2m, which is equal to 1. Right, so that is one of my roots. Okay, and then the other one, this one here, I'm not going to squeeze on here, I'll do that on the next slide. So I've got x is equal to m plus 2 minus m minus 2 over 2m. So the top line numerator will be 2 plus 2, which is 4 over 2m, and that equals 2 over m. So my final answer is that m is not equal to 2, and the roots are x equals 1, or x equals 2 over m. Right, so what we're going to need to do just to check before we finish it off, because we've obviously done quite a bit of work on that one, is to reread the question and just make sure that we've answered it exactly right, because as it turns out we haven't, we've missed something out. So we've got the quadratic equation has got two positive real roots. So we've found the possible values of m and the roots of the equation. Now what we've got to remember is the roots have got to be positive. So it's not just that m is not equal to 2. That root is always positive, x equals 1, but we need 2 over m to also be positive. So m must be a positive number and m can't be equal to 2. Right? So we have to go back and fix up our answer to the first part. So correct answer here should be that m is a positive number and m is not equal to 2. And the roots are this and this. Okay, that's all for now. Hope that made sense. Come and see me if you've got any questions on that one, because there's quite a lot to it. Thanks for watching.